what happens if you don't want? If you don't want the reflected wave, V, I write down everything again. VL equals to V0 positive exponential J beta L plus V0 minus J beta L. Okay? If I don't want this term, that means your gamma equals to 0. To make gamma equals 0, you need to make ZL equal to Z0. Okay? So, actually for this equation, you have two choices. You make your ZL equals to L, or you make your ZL equals to 0. You change this one, or you change this one. Okay? Okay, and usually you change this your. It depends. It depends your case. It depends your case. If your transmission line is 15 ohm, you want to get rid of the reverse voltage. You connect this transmission line to an impedance equals to your transmission line characteristic impedance. If your transmission line is 15 ohm, you connect to 15 ohm, and you can obtain the result. So your ZL is Z0. Then for this case, your Z equals to okay, 2 points, okay? Okay, 2 points. I think you want more points, so your Z in just put the same equation and then change all the ZL to Z0 and then equals to okay, thank you. 2 points. If your transmission line has a characteristic impedance Z0, connect to Z0. Everywhere it is Z0. Okay? The same. And what happens if you have different lengths? The phase is different. Remember the equations. You have what is the reflection coefficient? So this one will equals to, the reflection coefficient everywhere equals to, yes. No matter the phase is, everywhere goes to 0, because the reflection coefficient at L will equals to, remember what we already did, will become the reflection coefficient at this one times exponential minus J 2J beta L, right? Remember this one? Because this is a positive. It will be the minus. So, because this is 0, so no matter the phases, the answer will be always 0. if this is a perfect match, Z0 equals to ZL exactly, ideally. Okay. Two more cases. But before that, I want to ask you a simple question. 2 points each. I want you to draw the picture. I want 2 people to draw this is 2 pi theta. Okay, maybe I can have 3. Okay. Too small. Okay, you know what I mean. I want you to draw. I want 3 people. Just show me this is the sine theta. And this is cosine theta. And this is tangent theta. Okay, just 2 pi. Your hands. Come here. Anyone? One more. Okay, come here. 2 pi. Easy. This is 2 pi, pi. Okay. Okay. Draw these 2 pictures. Yeah, it's a hard part. Okay, so 2 and 2. I want a beautiful picture. You want 2 pi, I want a beautiful picture. I want you to draw it more accurate. Cosine is harder, right? Sine is easier. Okay, you need to write down where. Is that correct? Are you sure this is? Write down everything. And what is this one? Yeah, what is this? Okay. What? One tangent. Okay, 3 points. Tangent is more difficult. Use Are you sure? No, you use the same scale. Use these 2. Tangent equals to sine over cosine, right? Okay, 3 points. we define the electrical length, or sometimes we will say the phase. Sometimes we will say that phase. We define the electrical length of the microstrip line. We define that the transmission line is beta L. This is the term we use here because for these equations you always use the tangent beta L. Okay? This one equals to, what is beta? 2 points. Beta equals to, anyone? Raise your hand. Beta equals to, yeah, it's okay. I will give you any, give me any answer, I give you 2 points. What is beta? Okay. Okay, 2 points, okay. And more 2 pi over lambda, or more answer. I think we have more answer of the beta. What? 2 pi f? This is beta? You sure? This is omega. You think you need to think more carefully. Anyone? Omega over Vp times L. Yes, that's correct. Okay. Okay. I will use. Okay. Those are from before the midterm. Those are just try to help you to review. Okay. But I will use only this one. Okay. We have something special happen to tangent theta. What happened? We try to look at that. It is repeatable, right? It is when it is 0, when theta equals to 0, tangent theta is 0. When tangent theta is pi over 2, it is infinite. When it is pi, it is 0. Okay, let me write down 2 things we obtain from here. Tangent pi over 2 goes to infinite. This is the first one. Tangent pi equals to 0. This one. Okay, there are 2 cases, and we use this equation. Okay, let me. Don't have space. Okay. For the case tangent pi over 2 goes to infinite, for this case, if pi over 2, if theta equals to pi over 2, which means beta equals to pi over 2. What happened? Anyone? Okay, 2 points.
Lambda over 4.
You need to give me an equation. What will be L
equal lambda over 4.
lambda over 4. And the beta is 2 pi, because beta is 2 pi over lambda times lambda over 4 will equal pi over 2, right? Okay, 2 more points, the same. What happened if, what is the z in? If lambda, if your length is lambda over 4, or I say, what happened if your theta is pi over 2? What happened? For this case, your tangent pi over 2 goes to infinite, right? Can you tell me, Wang Xiuwen, and you ask you the same question, 2 more points, then your z in will equals to, from this equation, come on, come, no, I don't want you to see the answer, just come. I want you to give me the result for 2 more points. If your length is a quarter wavelength, Z in will become I want you to write down everything and derive. Yes. I want you to write down everything. Your beta is big. Okay. Okay. So what happened if your L is pi is lambda over 4? This one is infinite, right? So which one will be disappear? Yeah. Okay. So this one will equals to. You missed something. Yeah. This one will equals to. Yeah. Okay. Okay, good. 4 points. Another case, anyone? If tangent, I want to use another point. Tangent pi equals z. I want to use one. Anyone? Raise your hand. Come here. Okay. Just come. Okay. So for this case, beta L equals, just finish everything I want. Beta L equals to L equals to what? This is not what I want. Wait. Okay, let me lead you step by step, okay? I want to use this. I want to use this because this is a spatial point. Okay? Okay? This is beta L, okay? Beta is 2 pi lambda times L. This one equals to pi. So L equals to maybe you are nervous or something. I want to help you to finish. For this case, L equals to, yes. Okay, so for this case, what is the Z in? Input impedance. Do you want to use the equation? Okay, I think it's not so hard. You just tell me why. Tell me why. Because 0, right? So this one equals to yes. So Z in equals to L. Yes. Okay. 4 points. Okay. So you can obtain two results. If your wavelength, your transmission line, is the length of your transmission line is lambda over 4, your input impedance will become Z0 squared over ZL. This is the first case. If your transmission line is half length, half wavelength, your input impedance is the same as your load, which means there's no change if after half wavelength. Okay? Anyone need the time to write down? Or you can go back to watch your video actually. So we only take a break. So a quarter wave transmission line is very important. I assume that all of you already knew. That will change a lot, or you maybe sometimes you will make that impedance transformer. Okay. I want to, let me think. Okay, more questions. Indeed, sir, I have asked you a questions many months ago. Do you remember? Now, it's back into you. What? Yeah, today I think I tell all the details clearly. What is the reflection coefficient at some length if the length is a quarter wave transmission line? 5 points. You can answer the question. If you cannot answer the question, I will ask someone else. You can write down the general definition and put tangent beta L of the quarter wave transmission line in there. Can you? Do you want to try? What is Do you remember this one? I tell you the answer of this equation with picture. If you connect this one and this one L equals to lambda over 4, you measure log. It is the S11 you make the picture you look at 20 log absolute value of this one, and this one is something that this is S11. Couple of months ago, I told you to simulate this. Use your software, right? Remember? The picture of this one will become S11. Remember? And, this is maybe 0 is not here. 0 is up. Then this is like and this is 1. This is 0. 0 dB. Do you want to try? What's this? What is the definition of gamma? The reflection coefficient at here, if this is the quarter transmission line, I connect to something. Remember? I think you remember, because I asked you to do, but you didn't do anything for me. Now it come back to you. Yeah. What we are doing here is the same thing. No, you don't want to answer a question? Are you listening? No? Okay. Anyone? What is the definition of this one? We just do this step by step. Shifuya, do you want to do it again? Yeah, it's always your question, right? Come here. Yeah. You answer the same questions 3 times and obtain a point 3 times, right? The same? Yeah, the same. Okay, yeah. Two, but it depends on can you put the answer in. How long you can derive. Okay, so if L is a quarter wave transmission line, yeah, then which one will change? Just do that by yourself and do whatever you can. Yes. And which equals to the more, do more. Okay. Yeah, you can obtain more than 2 points because you do more. Let me help. I separate this one into 2 parts. For this term and this term. Okay? For this term, it is gamma 0, right? It will equals to, if you finish everything, you deserve 5 points. Yes, and for other term will equals to yes, and beta equals to beta equals to, change your beta. Beta is, you can as control, right? Yes. Don't forget your J and 2. You have 2, right? Oh yeah, okay. Yes. Okay. Okay. You can get 5 points, but this is not exact the result we try to simulate on your software. Why? Can anyone tell me? Okay. 5 points. Okay. Thank you. 5 points. Why? What is this? Minus 1, right? What? Where is this f? In this equation, there's no f. So result is the same. So for this case, what do we do? What should we do to change? I'm asking you the questions more than the textbook. This is happened in your ADS. Where is F? Can anyone answer me the question? This is a 5 points question. Just tell me, where did we make mistake? Where? If this is minus 1 and everything is designed, but why we can see this picture? Not exactly. That's the time domain. We can use this equation to have this picture. But where we have f? Where? Close. Where? Where is F? 5 points. Raise your hand. Come on, 5 points. We need to be fair. Why we can see this picture? First of all, this is 20 log. Okay, you take a log and times 20 to become the dp. Right? But it is still something related to reflection coefficient, right? But why this one looks like this one? Okay, think about that. I will ask you maybe next week, 2 weeks later. Next week we don't have class, right? Okay, that's it.